next panel, how to introduce AM final parts in consumer goods, healthcare, and industrial application, is moderated by Isabel Sanz from HP, joined by fellow panelists Daegu and Crystal and Eileen. Welcome, everyone. I'm just going to check if Isabel here with us to put her on the stage. Yes, here. Great. Okay.
All right, ladies, you're all set.
Okay.
You're on the stage.
Yes, thank you. I added Isabel to stage. Hi, Isabel.
Hi, hello everyone. Can you hear me okay?
Yes, we can hear you all okay. Are you all set, ladies?
Yes, we are. Perfect. So yeah, great. Thanks, Malika, for the presentation. Yeah, hello everyone, and thank you for joining us in today's session. As Malika mentioned, my name is Isabel Sanz, and I'm the category manager for the Americas region in HP. And today I have the pleasure to have with me three wonderful work colleagues that you can see in the camera there. And we have prepared actually a very interesting topic that is gonna go through how to implement final parts production in so additive manufacturing parts in final parts production in three main segments that they are leading, being consumer goods, industrial equipment, and healthcare. But yeah, before we go into any further detail, I will pass it over to them so they can please introduce themselves. So yeah, please do you go ahead.
Hello, everyone. I'm Duygu Ginay. I'm the segment manager for the industrial segment, essentially driving 3D printing adoption in the robotics, automation, and machinery ecosystem.
Hello, everyone. I'm Marcela Fernandez. I'm Worldwide Healthcare Segment Manager.
And hello, everyone. I'm Crystal, and I work with Duygu and Alien, the segments team, and I'm focused in the consumer goods segment.
Okay, perfect. Thank you. So as I was mentioning before, today what we want to share with you is a story, and is the story of what we've seen that has happened in additive manufacturing in the past years. And in order to do that, the three speakers that we have today, they have compiled a series of stories as well of different customers that have like really taken the best of additive manufacturing and introduce it in their final products. But before we go into the specifics for that, I would like to start providing a little bit of a context of why is that so important. So if you think about additive manufacturing or 3D printing, this is an industry that has existed already for more than 30 years. But traditionally, 3D printing has been used in prototyping. So why is it possible, actually, that now we have really done the shift from this prototyping into final part production? So one of the things that we see in HP is that there are like three main pillars why that is happening. The first one are the printers and the technology. So we have printers today that are like really more productive and can really provide volumes of parts at the scale that is really needed for final part production. The printers are more reliable. They are like really fulfilling the accuracy that the customer needs and that repeatability for the final parts. So that is one of the pillars. And then, the second one is the materials, which are also a key thing for any customer that you talk about final parts. And today, one of the advantages as well, or one of the improvements that has happened in the industry is that we have materials that are very comparable to materials, for example, that are used in injection molding, which is one of the main technologies for this final parts production. And they have similar mechanical or even dimensional properties, but are also materials that are more isotropic, so are simulating like better what an injection material is doing. And then there's a third pillar, which is all the design for additive. So there's been an effort by different players in the industry that is actually shared with everyone, which are the best practices, how to design for additive. I always say that printing something in additive or manufacturing something in additive is not just taking something that you have designed for injection molding, for example, or CNC, and just take it and print it with a 3D printer. That's something that you can do, but most likely you are not going to get the best of it. So what we've seen in the past years is that actually people have started, or the engineers, the designers have started to think into which is the function of those parts, what I'm really trying to do, and then really taking that concept and designing around additive manufacturing. And you will see today in some examples parts that cannot really be produced with any other tool. So it's like really a step forward that is driving us into that direction. Good. So yeah, after this short presentation to put a little bit of context in here, I'm gonna pass it over to my work colleagues so they can start sharing all the different stories that they have prepared. But before that, a couple of housekeeping items. So we want to give enough time at the end of the presentation to answer your questions. So I encourage everyone to go in the Q&A section or in the chat, whatever it's easier, to put anything that comes to your mind. We want questions, but we also would like to hear comments, feedback, anything that you want to share about this topic, because this is we are really passionate about it, and we want to make sure that we are answering and talking about all the points that you are interested in. And having said that, I will pass it over to Duygu.
Perfect. Thank you so much, Issa. As Issa mentioned, today we will be beginning with the industrial applications. So the first example of final parts that I really wanted to share with you is an example from Baumann from the UK. So these parts that you see in my hands here are bearing cages that are manufactured with HP3 11 material. This part before has been manufactured with aluminum in general, and then as they transition into 3D printing, Baumann identified the PA11 material as due to the wear resistance properties within the polymer portfolio of the HP 3D printing solutions. One of the best benefits of transitioning to 3D printing in this application was being able to improve the performance of the part. By transitioning into 3D printing, one, they were able to produce these parts much lighter weight, as well as being able to increase the axial load capacity of the bearings by 50%, which consequently increased the life of the bearings by 3 to 5 times in general. In addition to those part performance benefits, one of the things that really improved the process for Baumann was being able to assemble and demount these components much faster compared to the aluminum parts that they had previously before using 3D printing. Another benefit of using this material, the PA11 material, which is a bio-based material, is of course the sustainability benefits and the reduced carbon footprint that is associated with 3D with the plant-based material. The next example that I have is a bit of a large part in general. As you can see here, I'll try to show you this end-of-arm tooling that is quite an intricate design that is from one of our system integrators from Italy. As you can see here, they've essentially combined two different methods of manufacturing. 3D printing, where the complex design is necessary, where lightweighting is quite important, as you see in the end-of-arm tooling applications in the robotics industry, being able to reduce overall stress on the robot itself, also improving the accuracy and the precision of the robot arm. So they've kind of transitioned the use of 3D printing for these intricate designs at the end, having integrated air channels that really reduces the need for assembly in general, as well as reducing the risk of air leakage. And they've combined other CNC manufactured or injection molded components to be able to capture the part that is going to be manipulated in the production line itself. A big component in the robotics industry, in addition to end-of-arm tooling, is being able to have these integrated air channels, being able to use these airtight materials like PA12. And in addition to that, having cable holding systems or other accessories around the robot to make sure that the robot arm and the robot itself don't necessarily have any bulky components around it that limit its motion. The next example I have is another end-of-arm tooling example. This is actually from one of our parts providers in Germany. As you can see here, they've kind of pushed the boundaries a little bit by being able to use two different materials. An extensive FEA analysis was carried on this end-of-arm tooling, as you can see, and depending on the stress load across the part that you see right here, they've chosen two different materials to manufacture it in different ways. So on the front part of the application, you see PA11 being used due to its flexibility. And on the back end of the component, you see PA12 with glass beads being used due to the rigidity. So these are some of the different creative solutions that our customers have come up with for the final parts in general, being able to reduce the time it takes to manufacture these parts, as well as having a little bit more capabilities in-house to reduce their dependency on the suppliers. The last example I have is from L'Oreal, actually. As you can see here, these are the different design iterations for the jigs and fixtures that are placed on their production lines. These are with chemical polishing. These are our chemical polishing examples, and then this is the part that is just sandblasted out of the printer. And L'Oreal is essentially coming up with these jigs and fixtures to be able to meet the demands, the customer demands that require a lot of flexibility and production agility, especially when it comes to the consumer goods. So they're using 3D printing to prototype these jigs and fixtures essentially in-house, and then once again leveraging the capabilities in the industry, as Isabel mentioned, to be able to redesign these parts through different softwares to fit them with multi-jet fusion technology. And after being able to transition design into multi-jet fusion, they are leveraging HP's digital manufacturing network of certified production partners that can provide these components in various locations in the world. So reducing the need to be shipping the components, reducing the need for import and export taxes, as well as the carbon footprint in terms of logistics significantly, as well as being able to reduce the inventory and stock management processes. So these are some of the examples that I have from the industrial side. And with that, I'll pass it on to my colleague, Cristal, to go through the consumer goods examples.
Thank you. Hi, everyone. So I'm Cristal, and I will show some examples of consumer applications. So I'll start off with the Sync Alpha speaker. So the Sync Alpha actually is a brand new product, and that is bringing a brand new audio experience. So for this, they really wanted to be able to develop a part that could be iterated really fast, and that they could finalize with a final part that had all the requirements that they needed. So the here had to be actually a single part seamless, so the audio could travel around in the best way possible to really reach this triphonic experience. So they worked with one of our service providers, and they really managed to bring this innovation to the market and this final speaker that is now available in the US and in Europe. This is quite an interesting and recent example that we have in audio equipment. But then we also have other segments that are using it within consumer goods. So we'll start, for example, with Decathlon. As you may know, it's a huge sports brand. So they are actually using 3D printing and MJF in many of their departments. But in this specific example, they wanted to bring a new product to the market in small quantities. So they turned to MJF for the nose clip, as you can see here. And they're really able to find a great design that actually needed very little assembly as well, and met all the that they needed for this nose clip. And this is actually the first 3D printed product that they have online and that you can actually buy now at Decathlon. Decathlon is also actually using 3D printing for their sustainability goals. So Decathlon, what they noticed is that they had some items that the customers actually wanted to be able to repair them. It's not high enough for actually to continue production of spare parts. So what did they do? They noticed in this particular case for a ping pong table that they needed some spares, that they had a demand for it. And with their sustainability goals, they want also to increase the product life cycle. So what they did is that they analyzed some of those parts that were requested, and they actually added it to the catalog, creating like the 3D files. And now they're able to print on demand every time a customer needs a spare part. And today they have over 56 parts actually on catalog for spare parts that are available. So this is one way they're really using it to support their goals. Another interesting example in sports, and it shows a bit of all the customization possibilities that we have, is the Smith ski goggles. So if you look at the ski goggles, the frame of the goggles are actually 3D printed. And what Smith is doing is that they develop their own app. In this app, you can really scan your face. So you have the perfect goggle with the perfect frame that really fits all the details of your face. And this is really allowing like a perfect fill for the also perfect comfort for the whole day. So this is a great example of how customization is being used for final parts. I will finish off with also an interesting example. This time in decoration and in lighting. And this is like the blossom lamp that was developed by Davide Piccini in Italy. And the blossom lamp, what is really interesting is that each petal is unique. But on top of this, if you look at the lamp like this, it actually fits our build size to be printed. But as you open it, it's a lot bigger. So if you see, it has this beautiful shape of a flower. And it shows how we can really optimize design to actually be able to print this one part and it to fit our printer. So those are some of the consumer goods examples, and I will move forward to some great healthcare applications.
Hello, everyone. I'm Ashton, healthcare segment manager. So in HP, we do believe that healthcare is one of the biggest things that we have. We are really pushing to have more applications here. We are focused on dental, also orthodontic and prosthetic medical equipment, different kind of applications. And the main goal here is our customers are doing very cutting-edge devices and very patient-focused. So I'll show you a couple of applications. I'm with my projects today. So for example, just to kick off, this is a very good one. Is a phadia. So for the patients that have a socket, they are amputees. Essentially, the doctors can create in a couple of minutes, can ask for in a couple of minutes for this kind of designs. I'm very focused in the finishing and in the design of the devices. This has been made by one of our customers, which is unique. They are based in Spain, but selling worldwide. Examples that we have that I think is quite good is this kind of arm cast. The goal here is to have a very lightweight device and a very breathable device, because imagine someone that has a fracture need this kind of components to have a more comfortable experience. What is nice here is the doctor is recommending the technology and recommending their patients to use this kind of devices. And I think this is democratizing somehow the technology to have more accessibility to these kind of devices for the end patients. Another example here is very similar concept. This is for one of our China customers, and they are doing, again, a very lightweight devices. Hopefully you cannot feel it. I promise it's very lightweight and actually sort of breathable as well. But also what they can do here is treatment. So when the patient is using it, they can also try to move it and try to incorporate some movement to accelerate the treatment itself. I think the details as well are very, very nice. And let me show you another one here. This one is from Fitted. Essentially, it's a software company that happened to produce medical device. This one is a scoliosis brace device. As you can see, again, we are seeing the same things that we commented before. A very lightweight device, a very breathable device. Actually, this has been made with PP, which is very affordable, very convenient. It's quite flexible as well. And this is a different kind of benefits. So it's an aesthetic factor, which is important for the patients, I do believe, but also it's lightweight, it's breathable device. And from a producer point of view, you can produce more than probably 6 of this one at the same time. So this is helping the doctor to focus in the things that they're buying, not in the molding and so on. I think this is a very nice example on how customers are doing cutting-edge devices. And let me show you just one more. This one is a baby helmet. Hope you can see all the details. This is from Invent Medical, one of our customers as well. Again, if a baby is using this one, the things that we are looking at this specific application is a very lightweight device and a very comfortable device. And the good thing about Invent Medical is a biosensor incorporated to this device, so it can measure how the treatment is going. Invent Medical has a variety of applications, but I think this one is very, very, very nice. So we have a bunch of applications over here. I would love to walk you through all that we have, but I will leave you with Isa. And actually, my colleagues are coming. So if you have questions, if you want to see more application, happy.
Good. Yeah, great presentations. And yeah, thank you so much, especially, yeah, Aye, for being here today with the crutches, which has like a special challenge added on top of it. But yeah, awesome explanation. So thanks so much. And yeah, actually, we have a few questions already in the Q&A, so we can jump directly into that. Yeah, there's one that is getting the highest quantity of pods, which is what applications do you see have the highest potential for true production scale printing in the near term? And probably if you can categorize them, like which are the best applications, the sweet spots for multi-jet fusion?
So starting for healthcare, I do believe orthotic and prosthetic field is one that is full production. All our customers are producing the parts for the final patient. So this is one of the areas when we are seeing productivity and production 100%. Also, dental is another area that we are working with, and our customers are doing full production as well. But I don't know, I will leave my colleagues as well too, and for the other segments.
Yeah, for industrial within the robotics industry and around toolings in general is somewhere where we see a lot of the MGF components come to life from our customers due to the airtightness of the materials, as well as being able to create lightweight components that really reduce the stress on the robot, which in some cases enables smaller robots, which means less capital investment for the end users, as well as less energy consumption, which sustainability. Or on the machinery and equipment manufacturers side or manufacturing lines, wherever you need agility in terms of production, wherever you need flexibility in terms of the components that you're producing, let's say short runs of tens to hundreds to 1,000 components, where with traditional manufacturing technologies, you would have to create a mold. Any design changes would require expensive and time-consuming processes in general, or you might be saying no to some requests from customers due to minimum order quantities in general. So all of those things that some of the companies are not able to achieve today with traditional technologies, 3D printing would be a good alternative for that in the industrial space.
Yeah. Now, in consumer goods, I think it's really important to look at those applications where we need a lot of customization. So something that is really fit for and needs to fit for the client, for the customer. This is where a 3D we can really make a change, because we can really print different specific parts for the person at once. So this is one thing. And also all the different design possibilities, right? So if you look at maybe limited editions and you wanted to make very fast, bring a short line to the market with specific details, and really give change to the portfolio of possibilities you have in your brand.
True.
Great. So yeah, thanks for. Yeah, no, absolute. Yeah, great answers. So now we are gonna move into the next one. It's about sustainability. And yeah, I have to say that sustainability is actually one of these topics where we see that is growing and growing the attention that all the companies and also the consumers are paying up. So it's actually one of the areas where we at HP are looking forward to keep improving, keep adding more of a circular economy with our products. And yeah, the question is actually related to that, right? Yeah, how sustainability play into the final parts production with 3D, and how that compares with other industries.
Mm-hmm.
I mean, so there are a lot of options with 3D printing when it comes to sustainability. The biggest component probably is on the raw material waste. You're only printing exactly the components that you need. And in most cases, you are actually able to reduce the amount of raw material needed to 3D print the part without sacrificing any of the part performance or the mechanical properties. So that's right off the bat is a good example of how we can contribute to sustainability. And what we see with a lot of the customers, it doesn't necessarily stop at the creation of the part, but we have some examples like part recyclability programs. Ford is a good example of that, where they're basically using unused powder or some of the parts to regrind them and use them for injection molded components. So ecosystems like this, where 3D printed components or outputs are used for more components or recycled, is something that we'll probably see a lot more in the near future as well. I don't know if you guys.
good. Actually, talking about the waste reduction. So the customer manufacturing OMP devices are commonly coming from CMC, and this is one of the things that they're claiming the most, right? So they can reduce all the waste material that they have with the previous technology. And probably another point related to this is the produce locally. This is something that is related to sustainability as well, and we are seeing a lot, and this is what 3D printing is enabling somehow. We do see this with the COVID situation in HP. We have been working quite hard on it, and we have the ability to make our customers to produce locally. We do think this is also helping from a sustainable point of view.
Yeah, and I would also add as well, like the produce on demand as well, because I guess you don't need like the warehousing, and you don't have waste product that might go to waste at the end, as we showed also the Decathlon example for spare parts, which allows them to not have the inventory of spare parts, but also to increase the life cycle of the product. We also have Hylas. We have a shoe behind we can show after. Yeah. Okay. We also, like, they gonna buy your shoe, but at the end of the day, you can return it and then recycle it, and then you get like a special price on your new pair of shoes. So this really makes you not keep buying products, say, once every week, but you really keep a product that is high quality, and then this will be recycled at the end and used for a new pair of shoes.
Great. And yeah, actually Hylos has been in the conference as well, presenting what they are doing in terms of the design, which it's very interesting. It's like really step forward in the footwear space. Good. So let's move into the next question. Which is about the supply chain disruptions. I've seen as well that there's been some particular topics. This is as well something that it's very concerning for different companies on how they can prepare for the next pandemic, or how can they like really reinforce their supply chain to avoid disruptions as the ones we've seen in the past couple of years. So which has been your experience during 2020, 2021 with the supply chain disruptions?
Yeah, actually in 2021, customers increased production significantly. And as I mentioned before, with the COVID task, we do see all this effect of how you can simplify the supply chain and the with that. This is one of the things that our customers are claiming the most, and we do believe in how 3D printing, but I also believe that this is one of the magic of 3D printing, right? How we can simplify all this process and make more accessible in somehow democratize the technology for everybody.
And that really speaks, I mean, so far up to 100 million parts have been 3D printed with HP's multi-jet fusion technology. And we have actually seen that number pick up quite significantly as well over the past year during COVID in general as well. So it really shows how 3D printing can either replace or complement existing traditional manufacturing technologies to really fill in that gap where supply chain might not necessarily be fulfilling the requirements according to the demand in the market today. One example that I shared with the jigs and fixtures is probably a good example of that, being able to have a resilient supply chain, being able to meet the needs of a production line, being able to be agile in terms of responding to changes quickly, and being able to get components in a matter of days instead of weeks or months is proving quite significant in terms of benefits of 3D printing. And I assume we'll see of that in the near future.
Yeah, again, it's built per order, right? So.
Good. So let's talk material, changing wheels here. This is, a very common question. Which are the materials that we have in the multi-jet fusion portfolio?
So, I mean, we can start off with the easiest one. So the PA12 material is probably one of the most common materials that is used in the 3D printing industry. Of course, that's what we see a majority of the art coming out of printers that are located in the world today are with PA12. So that's kind of the baseline material where you need impact resistance, whenever you need air tightness, whenever you need different design that is specific to the task at hand. So PA12 is a good example of that. And PA12 with glass beads, example where a little bit more rigidity is required in some cases, which we see a lot of those examples in the end of untooling space due to the stress load on the components themselves. So I'll hand it off to you guys.
So we have PA12, as you say, but also we have PA11, which is probably one of the materials that people are starting to use the most. Also, we have PP materials and TPU materials. One comment in healthcare is very important to have biocompatibility, and materials are biocompatible, which is nice. And a trend that I'm seeing is blend of materials for the same application. So people is starting to combine materials in the same applications, which is nice, and it's also something that they cannot do with other technologies. So I think we can differentiate in that way. So PA12, PA11, PP, TPU, TPA as well. Yeah.
No, just say TPU, especially when you think about the applications and you need some sort of comfort when you want to find a new sort of performance, like position for the shoes or for like the goggles, and how this is going to be in the person, for example. This is also a great material.
And probably one of the biggest things that is setting HP up within the industry is, of course, the recyclability of the material. So within the material portfolio, usually 70 to 90%, depending on the material, there's material recyclability. So you're not necessarily just using the powder that really goes into the machine and then that's it. So this is probably one of the highest material recyclability rates you see in the industry, and that really sets it apart, the material portfolio of HP in this case.
Mhm.
Great.
You have
a lot of experience in it as well.
I was gonna do a quick comment. So sometimes it's not very clear like which is the material that you may require for the application that you have. If you have questions about that, what I would recommend is that you reach to your HP representatives in your region. If you don't know who those are, please feel free to reach out to me. I have the profile, the LinkedIn profile in my profile here in Remo, so you can reach out. We will redirect you to anyone that can really like help you and support you in that. But I would say that about the materials, it's important that you not only try to replicate one-to-one as well. So you may have a component that you are producing in ABS, for example, in injection molding, because ABS is one of the most used materials. That is probably a part that could be replaced and could be produced most likely with PA11, for example, or PA12. So we can help you to have all of those conversations and go through that. And I would also add that in automotive, what we've seen is that we have a lot of traction from OEMs, new companies, for example, in the electric vehicle space that are looking into polypropylene, because in there, it's interesting for them to have this one-to-one comparison, where they can use 3D printing for prototyping, and then afterwards they may produce with injection molding, depending on the volumes, also with the polypropylene in injection molding, or they can take the 3D printing and move it into production as well. So do the final parts with this polypropylene in the final cars or the vehicles that they are producing. So there are a lot of options, a lot of opportunities, and we are here to support you. Good. So let's change wheels here. And there's another question that is getting some votes, which is about the limitations. No, we always talk about what we can do well. Let's also be honest here and talk about which are the things that we cannot do or we don't recommend you to do, because there's like no really a very good sweet spot for multi-jet fusion.
So probably right off the gate, any component that saying in millions, so anything that is a little bit more suitable to injection molding in that case probably might not be the best candidate for 3D printing. So that is essentially the volume. When it is too high, can be a limitation of 3D depending on the certain case. Something that we see quite significantly in the industrial space, in robotics, automation, machinery, is large parts. So the build sizes of different 3D printing technologies, including HP's solutions, can be a limitation in terms of the large parts that are 3D printing and how those parts are mounted. But we see a lot more creativity coming into place when the designers or engineers become a little bit more comfortable with the technology itself. They do come up with creative methods to design around these components. So an end-of-arm tooling or a machinery component that might be, let's say, 2 meters in size today, manufactured with CNC machining, doesn't necessarily have to be 2 meters when it's coming out of the 3D printer as well. Being able to achieve that same performance with the mechanical properties can be done by changing the design and looking into the design to have a better design in general for that component itself. And as I shared with the Compatella and the Van tooling example, the large part that I shared during the presentation, that's also probably a good example of that, where we're seeing hybrid manufacturing technology. So combining 3D printing is what makes most sense for that, as well as CNC machining or injection molding components and mounting those, coming up with different mounting technologies or processes as well, to make sure that you arrive at the right part with the right cost structure as well as the component.
I think we covered it quite well, actually. Yeah, we had another example as the lamp behind, also for the size and how it doesn't have to be big from the get-go, like the product is going to come out, but how you can play with design for it to optimize it.
Yeah, actually talking about that, one example of this application, the scoliosis brace. In the past, we cannot do it without, because it's probably too big, but the customer now are cutting it and they can fit a lot in the build chamber. So I completely agree on what you said about the size of the parts and of course the quantity, but we always of course look at the obstacles.
Okay, perfect. So then let's move to the last question of today, which, I think it's a question you are going to enjoy. Like, do you work on design as well? So what can we do in terms of design skills or capabilities?
Something that is important on design, I will say that we have a lot of customers coming from injection molding, for example, and what I do see is they are trying, and probably this is difficult to avoid somehow, is they want to put the design that they used to have in the injection molding in the 3D printing technology. And we encourage the people to redesign the part thinking in 3D, because there are value added when they do that, right? And I really can have a lot of cost reduction because they can simplify the design. And I think this is one of the best advice that we can give them. We have different ways to support them. We have a huge team of application engineers that are helping application per application on how to overcome all the obstacles. I will let my colleagues keep answering to them.
No, I think you're totally right. And as you said, we need to design for additive manufacturing. And I think, we have all the tools to support people with that.
Yeah, and probably one of the, let's say, most common ways people adopt 3D printing for final parts, or at least what we're seeing from our customers, is, of course, as I mentioned initially, having those designs that are designed for an alternative technology and trying to 3D print those and not necessarily getting all the benefits that we all talked about today. And then as they get a little bit more comfortable with the technology, they transition into simpler design methods related to 3D printing, and they try to integrate those, like parts consolidation is a good way of doing that, or latticing or allo structures is a good way of reducing the cost, reducing the time, as well as reducing the weight of the components. But the real benefit of 3D printing comes to life when specifically for additive manufacturing, where the only limitation essentially becomes the imagination of your engineers, of your design team, and maybe full production machine HP 3D printing solutions or a desktop 3D printer. That probably might be a good toy or a good gift to give your engineering teams or design teams to begin experimenting with the idea and get comfortable with it in general.
Mm-hmm. And I would add to that we have a very good training online. So if anyone is interested in learning more, if you Google HP 3D DFAM, which stands for Design for Additive Manufacturing, then you will find a page where you have like all the different trainings that you can take. And actually I've gotten very good feedback from engineers, designers that wanted like to really expand their capabilities and like push the limits. What we are looking for are like companies, design engineers that are like really pushing the limits of the technology and showcasing what can be done. Because we don't know it today. And you've seen in some of those examples that they've showcased that there are like very intricate and complex structures that you can create. Good. And with this, I would like to thank Cristal, Ayelen, Duygu for the presentations today and for taking the time to participate in this panel. Hopefully it was insightful for you to bring a little bit of that story of what we can do in additive manufacturing in final part production. So it is a reality today and it can be done. And you've seen some proof of that today. And I would leave you all with one question that I would like to ask you to think about, which is that what can I do? So I'd like everyone to ask themselves, what can I do to participate in this enablement of final parts production? And with this, I will pass it over to Malika.
Thank you, Isabel. Thank you, ladies, for this amazing and interactive panel. We got the chance to see different applications. That's really amazing. And I will encourage the participants to join you on the networking session that will start in a few minutes. Please feel free to storm these ladies with a lot of questions. They were amazing. Thank you. You guys rock. Okay.